Java polymorphism. So we'll talk about what polymorphism is and why polymorphism is useful, and we are going to see examples of polymorphism in Java program. We are going to use a very simple example, and then we are going to talk about three different forms of polymorphism. So you have already seen two examples of polymorphism already using overloaded method. That's one example, and the second example was using abstract class and abstract method. In fact, the third example is going to be usage of interface. Okay, so we're going to use all those three schemes to have polymorphic behavior on our online application, online shopping application. Okay, so what is polymorphism? So if you search for a dictionary, if you look up the dictionary, polymorphism is defined as an ability to appear in many forms. Okay. Now, in the context of Java, polymorphism refers to the ability of a reference variable to change behavior according to what the object instance is referring to. So we have seen examples of this one already several times in our previous examples, right? So it allows objects of different subclasses to be treated as object of a single superclass while automatically selecting proper methods of those subclasses to apply on the subclass it belongs to. Yeah, on the subclass, I should say. Or if it is in fact the implementation classes of interface, then when the method when a reference type is interface type, the actual implementation class object will be actually used for the behavior. Okay, so let me actually just talk about this red colored statement one more time. I'm going to actually use an example in the following slide. It means is the ability, it refers to the ability of a reference variable, okay, or argument variable, to change behavior according to what the actual object instance is referring to, is pointing to. Okay, so let's take a look at an example. Suppose we have a parent class called shape. And then it has multiple child classes like a circle, rectangle, and triangle. Now, shape parent class has compute area method. Okay. Now, if you think about it, different subclasses in this case, circle, rectangle, and triangle, they should have a different implementation of compute area because they have to use a different logic for computing the area, right? The way you compute the area in circle is different from the way you compute the area in rectangle, and the same thing for triangle. Okay, so the logic of each of these subclasses should be different. Okay. So this is a great example where we could actually make a shape as a parent class and then child classes, and child classes provide overloaded method. Okay, so that is an example we're going to actually see. So polymorphism enables the programmer to provide different implementations of compute area for any number of child classes of, in this case, shape parent class. So we now have a circle, rectangle, and triangle. In the future, we could have octagon or XYZ, all those different child types. Now, no matter what shape an object is, meaning no matter what subclass compute area method is invoked, applying compute area method on the shape class, okay, it will actually use correct implementation of compute area method of the child class. Okay, so this is, again, we have seen examples in our previous presentation, right? Okay, all right. So we're going to actually use very simple example to see what's happening. So let's say we have a person class, and person class has two child classes, student class and employee class. Okay, and person class has a getName method. So student class will extend person class and provides its own overloaded method. So student has getName implementation, and employee also has getName implementation. Okay, so each of these child class, student child class and employee child class, provides its own implementation of get name. Okay. Now, when we create, so in this example, we created student object and then we created employee object. Okay. Now we are going to assign the student object to person reference type. So in this case, person is the parent class, right? Now, by using this reference person object, which is a type of person, we should be able to call that person type's get name method, right? Now, when you call this get name method, because this reference object, reference type, is pointing to the actual student object, it's going to use the student class's implementation of get name method. It will invoke the get name implementation of the student class. Okay, is that clear? All right. Now this time we are going to assign employee object to the person reference type. Okay, and then we are going to use reference person object to call get name method. This time, because this reference person reference type is pointing to actual employee object, it will call get name implementation of employee class. So this is a polymorphic behavior. So even though we are calling get name method of the parent class, the actual implementation of the child class will be invoked. So it actually provides a different behavior. So that's what is called the polymorphic behavior. Okay, so this is a complete code. So again, let me actually go over this code one more time. So we have created student object and employee object. Now we are assigning student object to person object, person type. So this reference person is pointing to actual student object instance, right? So when you call the get name method, it's not going to call the get name implementation of the person class. Instead, it will call the get name method of student class. Okay, the same thing of this guy. So depending on which object it is pointing to, the implementation method of the pointed object gets invoked, and this is a polymorphic behavior. Okay, all right, question from Roger. Okay, does the object change as a result of the behavior changing in polymorphism? No, there is no change. Okay, so there is no change in the object instance. So the thing is that the reference type, this reference person variable is a reference type of person, but it is actually pointing to the student object. So depending on what it is actually pointing to, the actual implementation of pointed to class object class, let me actually rephrase it. So this is basically what I'm trying to say. Depending on which object instance is pointing to, whether it is pointing to student object or employee object, the method of the pointed object, object's class will be invoked. It's going to call the get name method of the student class or get name method of the employee class. Okay. All right. So question from Robert: can you force the application to use the parent class method of the same name, skipping the polymorphic ability? In that case, no, you cannot bypass that. If that's what you want, then you have to create the person object instead of the student object. Okay, so basically if reference type is pointing to a particular subclass's object instance, then subclass's method is going to be invoked. Okay, so there is no exception to that. Does that answer your question, Robert? Any other questions? Okay. Okay, so this is another example. So here we are using reference type. Okay, now we're going to actually use the argument type. So suppose we have print information method and it's receiving person object. Okay, so again, depending on what actual object instance you are passing to this method. So inside this method, it's going to call get name method, right? So depending on what this P is pointing to, different version, the different implementation method will be invoked. Okay, excuse me. So let's assume this is a print information method. Now inside our code, again, we are calling print information method. Now we are passing student object or employee object. And depending on, and then it's actually receiving it as a person type, right? Okay, so that's perfectly fine because a person is the parent type and we should be able to actually receive it as a person type. However, when we call the get name method, okay, it's going to actually use the get name implementation of the actual object instance. So in our case, it will use student classes implementation of get name. In this case, it will use get name implementation of employee class. Is that clear? Question. So that's the mechanics. Now we're going to actually talk about why this is actually in fact useful. Okay, so I want you to understand the mechanics of polymorphic behavior first. Any questions? Okay, so let's talk about why the polymorphism is in fact useful. So first, it provides the simplicity. Second, it provides extensibility. And those are two major benefits of polymorphic behavior. So let's talk about the simplicity first. Okay. Now, in many cases, you need to write code that deals with a family of subtypes. Okay. And then you need to write code that ignore this type specific implementation details and just want to interact with the base type of the family. So if you go back to, for example, shape example, right? We want to use this parent class of shape, yet we want the behavior of the child class. So that's basically the simplicity. Basically we don't have to deal with all these subclasses individually. Instead, we are going to deal with this parent class method, and the subclass implementation will be automatically be chosen. So it actually makes your code a lot simpler. So it provides higher level abstraction, which results in simpler code. Okay. So even though the code thinks it's using the object of base class or parent class, the object class could actually be the base class or any of its subclasses. Okay, depending on the type of object gets used. Okay, so in our example, we are all using the subclasses. Okay, right? But it could be the base class itself as well. So this makes your code easier to write and easier for others to understand. Okay, because your code is basically dealing with the parent class shape only, and you don't have to deal with all the subclass in your business logic. So that provides simplicity. Second is extensibility. So in the future, you might in fact add your subclass types to the family of subtypes. Today, the shape has the rectangle, triangle, and circle. Later on, you might in fact have a need to add other subtypes like octagon and things like that. Okay, but your existing code do not have to change because the existing code are using parent class like a shape class. They don't have to know that there is another subclass to be added, right? So no code change is required in order to accommodate the addition of other subtypes in your application in the future. Does this make sense? Question? And we're going to actually exercise, the simplicity and extensibility aspect in the hands-on lab. Okay, no question. All right, so let's move forward. Okay, so three forms of polymorphism. So basically three different schemes of polymorphism in Java program. The scheme number one is method overloading. So this is an example we've seen so far. So the example we have seen of this student and employee. This is actually using the scheme number one, method overloading. Okay, so methods of a subclass override the methods of superclass. Okay, so that's scheme number one. Scheme number two is that we can use abstract methods of an abstract class. Okay, so in this case, methods of subclass, okay, meaning concrete class implement the abstract methods of abstract class. So this is scheme number two. And scheme number three is implementation of abstract methods of a Java interface. So in this case, methods of concrete class implement the methods of all methods of interface. So we have seen examples of scheme one and scheme number two in our online shopping application. So we're going to actually see scheme number three as well in the hands-on app. Okay, so this is a scheme number one. Again, we are looking at this the person and employee example. So this is the example we have seen already. So in this case, person is the a class, and the student and employee is a child class, a person class. So basically, student and employee overload getName method of person classes getName method. Okay, so this is overload. Yeah, I should actually say overload. Override. What am I talking about? Overriding. Overriding is the correct term. So this is correct. I should say overriding rather than overloading. Sorry about that. Okay, so it's overriding a parent class. Okay, so again, this is an example we have seen so far. Okay. Okay, so that is an example one. So we have already seen this guy. Okay, so let's actually take a look at this guy. So you remember my online shopping application. Okay, so in this case, compute sale price, the product class, because it's a class, it has to have an implementation of compute sale price. Because it knows that it's going to be overridden, it actually provides some dummy value. Okay, and same thing for book. Okay, so compute sale, yeah, so in the case of book, yeah, it's actually providing concrete implementation of 50%, and electronics is providing 40% discount implementation, and TV providing 20% implementation. Okay, and now what we want to do is we want to add two subclasses to the book. So we are going to add child book and cartoon book. Okay, so we are going to write the child book, so it's going to extend book, and then it's going to override this compute sale price, and this one it will have 70% discount. Cartoon, it will have 40% discount. And then basically we just provide the testing logic, so we also add children's book and cartoon. Okay, but what's important is your business logic here do not have to change just because you added these subclasses. Is that clear? I mean, this is just a testing logic. This testing code is this information is probably coming from a database in production environment. Okay, and the actual business logic is getting the sale price and compute the total sale price and all that stuff. So this is the business logic, and this business logic code do not need to be changed at all. Okay, and that's one of the benefits of polymorphism. Even though you have added brand new subclass to your application. Is that clear? Question? Okay, so I'm gonna actually let you guys do this exercise. So basically you can use the My Online Shop application from Java Inheritance. So if you still have that application, then you can actually change that code to add these two new types. Okay. All right, I'll give you guys about 10 minutes to try exercise 1. Okay, so we just take a look at the first scheme using parent class and child class and using overloaded method. Okay, now let's take a look at scheme number 2. So here we are going to use abstract class and abstract method. So instead of using person class, concrete class, we are going to use person abstract class. Okay, so here if you take a look at the person abstract, basically, the get name method is an abstract method. Okay, so that is basically exercise number 2. So if you take a look at this guy, it works pretty much the same way. Okay, so instead of, in this case, product is abstract class, and compute sale price is abstract method. Okay, so we have already seen this example in Java interface presentation, right? Okay, and each of this class that implements this product abstract class should implement the abstract method. Okay, and also we add children's book and the cartoon classes, and they also should provide this the book is, yeah, so in this case it's actually overriding method because book is already providing implementation class, right? Okay, so in this case it's just overriding the method. Same thing with the cartoon. And again, the key point is that there is no logic change required even if you add a new subtype. So when you run this application, it should actually display the same information. Okay. All right. So since this is relatively straightforward, let me just finish up the presentation, and I'll let you guys do the exercise 2 and 3. Okay. Scheme number 2. Now, scheme number 3. Now we are going to use interface rather than abstract class or concrete class. So here we have person interface, and in this case, person interface is going to have get name as only abstract method, or there could be other abstract methods. Okay. All right. So that is exercise 3. So let's take a look at exercise 3 here. Okay. So in this case, we make so we actually create a product interface. So product interface has 3 methods: compute sale price, get regular price, and set regular price. These are all the methods defined in person interface. And then person implements person interface. And in this case, one of the implementation method is going to be compute sale price, and here it returns 0. Okay. And now the book is extending person class, and it's overriding the method. Okay, so change is pretty minor in this case. The person interface is, we just create a person interface, and everything else is pretty much, the same. Okay, and that is pretty much it. Okay. All right, so I'm gonna let you just run exercise 2 and 3 and see whether you understand the code, and if that's the case, we'll just move on. I'd like to finish up the exception handling today. Okay, so I'm gonna give you guys about the 5 to 10 minutes to do exercise 2 and 3.